Assalamualaikum. So we continue our second part for chapter 2. Okay, now I'm going to explain the objective number 4, which is to determine mole, relative atomic mass, relative molecular or formula mass, percent compositions, empirical formula, formula of compound and limiting reagent. So first we're going to look into the mole concept and Avogadro number. So first, atomic mass. Okay. Atomic mass is the mass of an atom, of an element, compared with the one atom of carbon-12. For example, an atom of magnesium have twice the number of atoms of carbon-12, so its relative atomic mass is therefore become 24. So by definitions, one atom of carbon-12 weight as 12 AMU. On this scale, we know that for hydrogen, the weight will become 1.008 AMU, while for oxygen is equal to 16 AMU. So for relative atomic mass, the weight average of all of the natural occurring isotope of the elements. So example here, for carbon, so the atomic number is 6, so the atomic mass is 12, because 98% of carbon-12 is actually naturally occurring in 4 elements. So daripada carbon-12 dengan carbon-13 ni, carbon-12 tu yang paling banyak ada secara naturally. So that's why kita ambil dia sebagai relative atomic mass. So naturally occurring lithium is 7.42% ialah lithium 6, 92% is lithium 7. So untuk cari dia punya average atomic mass of lithium, so dia punya persen darab dengan dia punya weight 6.015, dan kita tambahkan dengan persen dan weight of lithium 7 divide by 100, so kita akan dapatlah average atomic mass for lithium is equal to 6.941 AMU. So the atomic mass for each atom, each element represent in the periodic table. Okay, next we're going to look into mole. In here we deal with microscopic sample, maksudnya sampel yang sangat besar. Then atomic mass is actually too small. So become the idea, okay, from the before. We do have a special unit, so to denote a particular number of object. Okay, the mole is actually a unit to count number of particle. Okay, secara analoginya sama macam kalau kita sebut 1 dozen, kita ada 12 benda dalam 1 dozen. If you say it's a pair, so kita akan ada 2 benda dalam a pair of shoes. Okay, so kita ada 2 kasut. Kalau 1 dozen of egg, so kita ada 12 egg in a box. So sama juga macam mole. Mole is the amount of substance that contain as many elementary entities as there are atoms in exactly 12 grams of carbon-12. So as a simple statement, we can say that 1 mole is equal to Avogadro number, which is 6.022137 times 10 to the power of 23 entities of atoms, elements, molecules or compound. Okay, so we look one by one. So 1 mole of hydrogen atoms have 6.02 times 10 to the power of 23 hydrogen of atoms. Okay, 1 mole ada 6.02 kali 10^23 hydrogen atom. 1 mole of hydrogen molecule ada 6.02 times 10 to the power of 23 hydrogen molecule. So dalam 1 mole of water molecule, we have 6.02 times 10 to the power 23 water molecule. Okay, kalau ada 1 mole nitric ions, kita ada 6.02 times 10 to the power 23 nitric ion. Okay, so kalau dalam 1 mole of oxygen ada 6.02 times 10 to the power of 23 molecule. Dan dalam 1 mole of oxygen molecules ada 2 mole of oxygen. Okay, ni 1 mole oxygen molecule ada 6.02 times 10 to the power 23 oxygen molecule. Tapi dalam 1 mole oxygen molecule ni kita ada 2 mole of oxygen atom. So 1 mole oxygen molecule akan contains 2 times 6.02 times 10 to the power 23 oxygen atom. Okay. Next, we're going to look into the molar mass. Okay, molar mass is the mass of 1 mole of anything, it shows numbers atoms in grams. Okay, dalam untuk 1 mole carbon-12 atom, kita ada 6.022 times 10 to the power 23 atoms, which is include sama dengan 12 gram. Okay, dalam satu carbon-12 atom, kita ada relative atomic mass 12 AMU. So dalam 1 mole carbon-12 atom, kita ada 12 gram carbon-12. Okay, kalau dalam 1 mole lithium, kita ada 6.941 gram of lithium. So we can say that for any element, atomic mass, which is AMU, is equal to that atom molecule molar mass in gram. Okay, this is 1 mole of carbon, copper, and so on. So, what is important is this part. You should be able to interconverting mass, mole, and number of particles. So, from mole, okay, by using a molar mass, you can get the gram, the mass for the atoms element, and from mole also you can use Avogadro number to get the formula units. Okay, how many entities in each mole. Okay, and vice versa. So moles will be provide a branch from the molecular scale to the real world scale. So this is more concept. So I think that you are already familiar with this triangle. Okay, if you have mass, if you want to find a mass, you just times mole with molar mass. If you want to have mole, so you just divide mass with molar mass. Okay, so to get number of atoms, you just times mole with the Avogadro number and whatever. So we're going to look into one example. In this example, how many atoms are in 0.551 gram of potassium? So, ini adalah berat yang awak timbang menggunakan analytical balance. So, kita nak tahu berapa banyak atom dalam 0.551 gram potassium yang awak timbang. So, you know that 1 mole potassium, dia punya molar mass adalah 39.10 gram. Okay, so this value you can actually get it from periodic table. So 1 mole of potassium is equal to 6.022 times 10 to the power 23 atoms K. So nak dapatkan atom, mass yang kita ada adalah 0.551. So dalam 1 mole dia ada 39.10 gram potassium. So dekat sini you dapat dia punya mole. So nak dapat dia punya any atoms, you kena darabkan dengan Avogadro number, which is 6.022 times 10 to the power of 23. And then you akan dapat lah. Okay, dalam 0.551 gram potassium, kita ada 8.49 times 10 to the power of 21 atoms and of potassium. So okay, kita try one example. So here, helium is valuable gas used in industry. So how many moles of helium are in 6.46 gram of helium? So first 6.46 gram of helium, kita nak mole. So moles, 1 mole of helium, molar mass dia adalah 4.003 gram. So finalnya kita akan dapat 6.46 divided by 4.003, so we get 1.61 mole. Okay, ataupun kita boleh guna mole konsep formula tadi. So nak dapatkan mole is equal to mass divided by molar mass. So mass dia dalam soalan is 6.46 gram, molar massnya from periodic table 4.003 gram per mole. So you akan get a same answer. Okay. So next, okay, how many gram of CH2Cl are obtained in 2.88 mole of CH2Cl2? So dia dah ada mole, kita dah dapat mole, kita nak mass. So sama konsep tadi. Okay, kita nak mass. So mass is equal to mole times with molar mass. So mole kita dah ada dalam soalan, which is 2.88. So kita nak tahu molar mass. Macam mana nak calculate molar mass? So dalam setiap jawapannya kita kena calculate each atomic mass, kita kena sum up semua. So dalam ini ada 1 carbon, 2 hydrogen dan 2 chlorine. So carbon is atomic mass dia ada 12. Okay, hydrogen tu ada 2 darab 1. Untuk chlorine 35.5 ada 2 darab 2. So kita akan dapat 85.0 gram. So dalam untuk 1 mol CH2Cl2 atom molar mass dia adalah 85. So nak dapatkan mass dia, thus 2.88 mol is equal to mol darab molar mass. Kita darabkan, kita akan dapat mass dia is equal to 44.8 gram. So you can try the examples here. Okay, first you can determine the number of atom for lithium and calculate the number of bromine atom in 32 gram bromine. So you boleh try, okay, and then you discuss with your lecturer. So next we're going to look into the formula mass. Okay, what is mean by formula mass is the sum of the atomic masses in AMU in a formula unit of an ionic compound. So tadi kita tengok molecular mass for molecule. So formula mass is atomic mass for ionic compound. So examples here, sodium chloride. So dekat dalam sodium chloride ni ada 1 atom of sodium. So dia punya molar atomic mass dia 22.99. Okay, ada 1 chlorine, dia punya atomic mass is 35.545. So kita tambahkan dia, kita akan dapat 58.44. So for any ionic compound, okay, formula mass AMU is equal to molar mass in gram. So dalam 1 formula unit of sodium chloride ni ada 58.44 AMU. Okay, so 1 mole of sodium chloride bersamaan dengan 58.44 gram of sodium chloride. So here example, what is the formula mass of calcium 3 phosphate? Okay, so kat sini kita boleh tengok, okay, dalam satu formula unit of this ionic compound ada 3 calcium, 2 phosphorus and 8 oxygen. So kita darabkan each, okay, dia punya mole ni dengan dia punya formula mass untuk setiap atom, kita tambahkan, kita akan dapat 310.18 AMU. So equal dengan molar mass dia dalam gram. So AMU so equal lah dengan formula mass dia dalam gram. So ni ada beberapa exercise yang you boleh cuba sendiri. Okay, next kita pergi kepada empirical formula dan molecular formula. So apa itu empirical formula? Is a formula that give the simplest whole number ratio of atoms in a compound. So different compounds may have the same empirical formula. Example, ethene and benzene, they have a similar empirical formula which is CH. So step for determining empirical formula. So first you kena start with the number of gram of each element. Then from there you convert the mass into the mole. Lepas tu you kena divide each mole value by the smallest number of moles, calculate, and you round to the nearest whole number. Okay, kalau the number is too far to round, kita kena multiple each solution by the same factor to get the lowest whole number multiple. Okay, example, kalau solution tu tiba-tiba you dapat 1.5, so you kena multiply each solutions with 2, so you akan dapat 3. Okay, sama juga kat sini 1.25. Okay, kita kena multiply each solution in the problem by 4 untuk dapat the lowest whole number multiple. So untuk 1.5 dia punya lowest adalah 5. So example here. Okay, what is the empirical formula of a compound that contains 40% carbon, 6.67% hydrogen and 53.33% oxygen by mass? Okay, so kita cuba buat sama-sama. Okay, first kita assume persen ini kepada mass. So mula-mula dia punya atom kita ada carbon, kita ada hydrogen, and then last kita ada oxygen. So kita assume mass dia adalah 40. Okay, ni mass kat sini 6.67, this one is 53.33. Dan kita bahagi dengan molar massnya. So ini bahagi dengan 12, ini bahagi dengan 1, ini bahagi dengan 60. So kita akan dapat mol sini adalah 3.33. Sini kita akan dapat 6.67. Yang ini 3.33. So kita kena divide with the lowest mole. So kita dapatkan ratio kat sini. So yang paling rendah 3.33. So sini bahagi dengan 3.33. Ni pun bagi 3.33. This one pun 3.33. So your final ratio yang akan dapat sini 1. This one is 2. This one is 1. So empirical formula for this compound ialah CH2O. Okay. Next is molecular formula. So tadi empirical formula show the lowest formula, simplest way, simplest formula for compound. So molecular formula ni pula adalah formula that shows how many atoms ion of each element combine to make that compound. So kalau macam tadi, kalau ethene C2H2, kalau benzene C6H6, okay, itu adalah molecular formula dia. So once the empirical formula is found, the molecular formula for a compound can be determined if the molecular mass of the compound is known. Maksudnya kita boleh cari dia punya molecular formula lepas kita cari empirical formula. Okay, yang penting mesti ada dia punya molar mass. Mesti kita tahu. Okay, so step to determine molecular formula, first simply calculate the mass of the empirical formula, apa yang kita buat tadi, and then kita divide the molar mass of the compound by the mass of the empirical formula to find the ratio, and then last kita multiply all the atoms, okay, subscript dia, by this ratio to find the molecular formula. So kita cuba soalan yang ni pertama ni. Okay, for a compound whose empirical formula is CH2O. So the molecular mass was found to be 180. So what is the molecular formula? So kat sini tak payah carilah empirical formula. Tak mula daripada awal lah, kita dah bagi empirical formula siap-siap. So kita cari dia punya mass by using this one. So ada 1 C, ada 2 H, ada 1 oxygen. So 12 plus 12 times 1 plus 16. So you akan dapat 13. So nak cari molecular formula, mass ini dia punya molecular mass kena bahagi dengan this mass. So 180 divide by 30, so you akan dapat 6. So nak cari molecular formula sama dengan CH2O, kita kena darab semua with 6. So you akan dapat C6H12O 6. So ini adalah molecular formula for this compound. Okay, this is an example. So ini kita kena mulalah daripada cari dia punya empirical formula. So dekat sini kita masukkan composite, kat sini 4.44, this one 20 mol. So you kena cari dia punya mol, so divide dengan molar mass masing-masing. So you akan dapat 6.29, 4.44, and this one you akan dapat 1.256. So the lowest ratio adalah this one, so you kena bahagilah each ni dengan 1.256. So you akan dapat dia punya ratio dan you akan dapatlah empirical formula. So kat sini you boleh cuba buat and then you boleh discuss your answer together with your friend and lecture. Okay. Next is percent composition. So percent composition is the percent by mass of each element the compound contains. So nak cari percent composition, N times with molar mass of element divided by molar mass of compound times 100%. So N is the number of mole of the element in one mole of the compound. So contohnya macam this compound ada C2H6O. So untuk cari percent composition of carbon, so carbon ada dua atom dalam dua elemen carbon dalam satu compound ini. So 2 times molar mass dia 12.01 divided by 46.07. Ini adalah molar mass of the compound. So nak cari molar mass ni awak kena tambahlah 2 darab 12 tambah 6 darab 1 tambah 16, you akan dapat 46.07. So times dengan 100, you akan dapat inilah percent composition of carbon dalam molekul ini. Okay, and you boleh calculate for hydrogen and oxygen also. So bila you total up kat persen kat belakang ni, so you akan dapat total 100%. So ini daripada persen mass given, kita bercari empirical formula. Okay, ini yang kita buat tadi. So dapat persen dia, you assume dia sebagai mass, and then you buat macam biasa lah untuk dapatkan empirical formula. Okay, yang ni soalan sama je macam yang sebelum ni. Okay. Next is example here where 5 gram of acetic acid are burned in air, 7.33 gram of carbon dioxide and 3 gram of water are obtained. So what is the simplest formula for acetic acid? So daripada carbon dioxide ni kita boleh cari mass of carbon. Macam mana nak cari? So carbon 1 mol dalam carbon dioxide, so 7.33 gram mass dia, kita bahagi dengan 44 ialah molar mass of carbon dioxide times 12 sebab kita nak cari carbon. So you akan dapat 1.99 gram of carbon. Okay, daripada water kita boleh cari mass of hydrogen. So dalam formula ni ada 2 mole of hydrogen dalam 1 mole of water times berat dia, mass dia 3 grams divided by 18 adalah molar mass of water. Okay, times 1 sebab 1 is mole. Mass of hydrogen adalah 1 gram. So ia akan dapat 0.33 gram of hydrogen. So mass of oxygen, okay, mass of sample here kita tolak dengan mass of carbon dengan hydrogen yang kita dapat dari sini. So ia akan dapat mass of oxygen. So from here awak masukkan balik dalam ni, you calculate the empirical formula and last you akan dapatlah empirical formulanya. Yang ni you boleh cuba sendiri. Jawapannya you akan dapat CH2O. Okay, sampai sini saja part 2 untuk chapter 2. So kita akan jumpa next untuk our last objective, balancing chemical equation bersama dengan limiting reagent tu. Okay, kita stop kat sini dulu. Assalamualaikum.